Well, hi and welcome everyone to this Kaeser Compressors webinar. My name is Rich and I'm a Senior Manager with IEEE Global Spec. Today we have three presenters with us from Kaeser Compressors, Michael Camber, Neil Meltretter, and Werner Rauer. They are here today with tips to help you get the most out of your compressed air system. And with that, I'd like to pass things off to Michael to get us started. Michael, go right ahead.
Good afternoon. I'm Michael Camber, Kaeser's Marketing Services Manager. Thank you for joining us for our webinar. Today, Neil Meltretter, Werner Rauer, and I are going to share with you a variety of tips to help you get the most out of your compressed air system. I'd like to start by putting compressed air into perspective. Here's some interesting data published by the U.S. Department of Energy. A survey by the DOE showed that in the United States, 8 to 10% of all electricity generated goes towards compressing air. For industrial plants, compressed air can easily account for 50% or more of their electrical consumption. Additionally, based on countless compressed air system audits, the DOE estimates that half of all compressed air generated is wasted. The components of that waste are leaks, artificial demand, which is operating at a higher pressure than necessary, and inappropriate uses. If you think about compressed air as an input to production, 50% is a very poor yield. Given how much compressed air contributes to a plant's energy bill and how wasteful it is, it's vital to closely monitor and control it. Being proactive and vigilant will help keep energy costs and maintenance costs in check. This effectively increases the productive yield of this input. In our webinar today, I'll briefly address air quality and also leaks. Then, our engineering manager, Neil Meltretter, will discuss energy efficiency strategies such as storage, flow controls, compressed air assessments, and master controls. Finally, our product manager for compressors, Werner Rauer, will cover practical tips for any size system. This includes how to properly apply variable frequency drive, low and high pressure systems, compressor room ventilation, and maintenance. And as we're presenting, please be sure to submit your questions so that we can answer them during our Q&A at the end. Our first issue impacting productivity is air quality. Here are some common ways of expressing compressed air quality. The levels of air quality are broad, from plant air to breathing air. These terms are used fairly frequently, but they really do not have set definitions that prescribe a specific level of air quality. There is a set of specifications for compressed air quality. ISO 8573-1 sets classes for specific levels of particulates, water, and oil. Specifying the ISO class level for each contaminant based on the requirements of the application will provide usable guidelines for selecting compressed air dryers and filters. You take a specific level from each of the three categories to give the ISO class. For example, ISO class 2.1.1 would be class 2 for particulates, class 1 for water, and class 1 for oil. But most users and specifiers don't know what ISO class meets their needs, so how can they apply it? Well, if you know that a certain combination of dryer and filter models works well for your application, you can determine the ISO classes by looking at the specs of those products. Then you have a specification that you can use when you expand, replace, or replicate your air system. If you don't have an existing system to work from, use your network to find plants with similar processes. Often, your compressed air equipment vendor has the experience with other customers to know what works. Keep in mind that you don't want to overtreat the air. It will increase purchase and operating costs. For example, if a refrigerated dryer works well, don't use a desiccant dryer just to get a better class of air. Once you know what equipment you need to have the right level of air quality, here are some areas to monitor and check to ensure consistency. Ambient and inlet temperatures greatly impact dryer performance. That's why dryers have correction factors to help you properly size them. If your temperatures spike, your air treatment will not be able to effectively treat as much air. Make sure filters and dryers are sized correctly for the pressure and temperature of the system. Use the correction factors supplied by the manufacturer to ensure everything is properly sized. Consider worst-case conditions in the room where your dryer sits. Check the filter cartridges on your filters regularly. Service manuals can give an idea of how long the element should last, but if you have a high dust environment, for example, you will need to change out the particulate filter elements more frequently, both in the compressor and downstream. If you shut your air system down at night or weekly, when you restart the system, the air velocity will be very high until the system gets up to pressure. This can overrun your air treatment equipment temporarily. If you have sensitive equipment, you should consider what we call an air main charging valve to control airflow during startup. Drain valves. They should be on tanks, filters, dryers, and low points in the piping system. Are they functioning properly or due for service? Many have a test button that you can use to confirm they are working. Use zero-loss automatic drains to prevent compressed air loss. Now we'll leave the topic of air quality and turn to leaks. As I mentioned earlier, half of all compressed air generated is wasted. Leaks account for a lot of this waste. While the DOE estimates 25 to 30%, our many air studies at Kaeser show an average of 34% of all air is lost to leaks. And we've seen plants with leak loads higher than 50%. This impacts more than just your power bill. Leaks cause your system pressure to drop and the compressors to cycle on and off more. This drives up your production and maintenance costs, which in turn costs you even more money. By eliminating the leaks in your compressed air system, you can put the air you are already paying for back to work for you. These are all common sources for leaks in any compressed air system, and they would be the first places you would want to check if you suspected a leak. As you can see, many of the leak sources are in or near the points of use. They can result from poor workmanship, lower quality fittings, or simply lack of maintenance, such as not changing out diaphragms and seals. Leaks also occur in the distribution piping due to combination of material choice and workmanship. Threaded connections are generally going to leak more, but badly brazed or welded joints can be equal offenders. So just how much does a hole in a pipe cost you every year or even every month? As you can see here, if you have one and only one quarter-inch leak in your entire system, you'd lose approximately $1,500 a month, $18,000 per year, based on operating at 110 psi. Now imagine how many leaks your system probably has, certainly more than one. The amount of money you are losing every month adds up, and the leaks don't just stop at the end of the year. Calculating the annual cost for a leak is fairly simple. Take a look at the formula in the blue box. You simply multiply the leakage flow rate by the efficiency rate of the compressor times the annual operating hours times the cost for electricity. Typical compressor efficiency values for 100 psi are around 17 kilowatts per 100 CFM, but you can find that exact value by looking at a KGI datasheet for your particular model. The leak rates we find during a leak audit are typically in the 5 to 10 CFM per leak range. This is about $1,500 per year per leak. Now let's take a broader view of what the average system is losing to leaks. Of course, the numbers up here are just examples, but they can give you a general idea of what money a plant can be losing to leaks based on how large its compressed air demand is. The bottom line, this is money directly in front of you, ready to be added back to your bottom line. Next, we'll look at how to find the leaks so we can fix them. When you are considering leak detection, there are three methods: listen and feel, the soapy water method, and ultrasonic leak detection. The first two are the old school methods, and they are not very effective or practical for most plants. If the plant is noisy or you cannot easily get close to the piping and fittings, you will have trouble finding the leaks. These are the main reasons why ultrasonic leak detection is the industry standard. Ultrasonic leak detection requires special equipment, as shown in this image, but it has distinct advantages. It can be done from a distance. It can discern leaks even in a noisy environment. It can also give a volume level for the leak. This helps you prioritize which leaks to fix first. Many compressor vendors offer this as a service, or you can rent the equipment from them. The first time you are doing a leak detection audit, I would recommend hiring an experienced service company to do the ultrasonic leak detection and watch and learn. If you contract a leak audit, there are a few points to look out for. Not all service providers are the same. Make sure each leak will be tagged and clearly identified. A good audit will also provide you with estimated cost and savings potential for each leak. This slide shows an example of an audit report that Kaeser provides for our customers. Each leak is tagged with a bright colored numbered identifier, the location within the plant or room, the system pressure at the leak location, the decibel reading of the ultrasonic leak detector, some room for notes, and then the energy or total cost for that particular leak. This is just to give you an example of the type of information and detail you can expect from an audit, including the approximate leak rate and annual power cost to satisfy that leak. Since leaks vary in size, knowing the relative size of the leaks will help prioritize the order of fixing them. Even if you can only get to some of them, if you fix the worst of the worst, you'll have immediate payback. The latest ultrasonic equipment can also take pictures of the exact leak spot to make it easier to find them in the future or to pass on to third parties that will be doing the repair work. And if the equipment doesn't have this capability, it's still a good idea to document each leak location. It will speed the repair process. I'll close the topic of leaks by emphasizing that you have to be committed to fixing the leaks. Just finding them and tagging them only adds to your costs. This may seem obvious, but we've seen it happen many times. Plants do a leak audit, but don't commit the resources to fix the leaks. Now I'd like to turn it over to Neil Meltretter, who will talk about compressed air energy efficiency strategies. Neil?
Thanks, Michael. As Michael stated, compressed air is expensive to generate and wasteful. The good news is there are a number of ways you can optimize your system to get the most out of it and keep it running as efficiently as possible. These strategies range in level of technology and investment. Today, I'll cover both ends of the spectrum. On the lower tech, lower investment end of the spectrum, we can start off with compressed air storage. Adding in a properly sized receiver tank can benefit your system in a number of ways. If you have a part of your process that needs large bursts of air intermittently, you can use a tank to supply the extra air instead of adding another compressor. Tanks also improve air quality and reduce wear and tear on compressors and air treatment. When talking about tanks, there are two basic kinds, each with its own purpose and advantages. Wet tanks are located upstream or before any of the air treatment. Wet tanks provide some storage, but mainly they help with knocking out the initial volume of water generated by the compressor, as well as providing a control buffer for individual compressors. This reduces the load on air treatment and can improve air quality. Dry tanks are downstream of the air treatment. This type can add capacity to help handle any intermittent high-demand events, while providing the necessary air quality since they are downstream of air treatment. With larger systems, these tanks provide the necessary control buffer volume to the system so master controllers can tune the system appropriately. For both tanks, it's essential that they have a drain attached. We recommend automatic drains as they do not vent compressed air needlessly. An ideal system would include both types of tanks. However, for many plants, this is not possible because of floor space constraints. If that's the case for your plant, think about which area is the most important to you, moisture control or having a buffer of extra capacity. If you want to know how large of a tank you need, here are some rough guidelines. Wet tanks should be between 1 and 3 gallons for every CFM in your system capacity. Dry tanks, 3 to 5 gallons. I would recommend you go larger with tanks because this is the one area where oversizing is never a problem. Also, it gives you room to accommodate future growth and expansion. Also considered galvanized receivers, or internally coated receivers, as these will protect the receiver from rusting over time. When you consider that some receivers are installed for generations, we recently saw one from 1949, this can cause the internals of the tank to rust and scale due to the acidity of compressed air condensate, which then gets passed downstream to the end use. Whereas an internally coated tank or galvanized receiver can last much longer. If you would like a more precise size for your system, visit the online resources section of our website, www.us.kaeser.com. We have an air receiver calculator there to help you out. Our next lower tech and lower cost solution is to add flow control. When used in conjunction with the right amount of storage, flow controllers can improve pressure control. They do this by responding like a pressure regulator, but in a much more rapid and precise way. They react to changes in downstream demand very quickly and can release large volumes of air to maintain a steady system pressure. And flow controllers typically have a much lower pressure drop than a pressure regulator because they are able to handle large volumes of air. Flow controls have a number of benefits, and they can be especially great for older systems, ones that have outdated piping that it isn't feasible to repair or replace, and the leaks will leak less, saving money. And if the compressors don't have the communications capability, that's not a problem either. Keep in mind that if you have multiple modulation compressors running inefficiently, that will still happen, only the demand will be lower, which will lower the energy consumption. If you're interested in a flow controller, think about these three considerations. First, you'll need storage before the flow controller, and it must be stored at a higher pressure than what's needed downstream at the point of use. Second, the size or amount of storage will depend on the pressure differential. Less storage is needed as the pressure differential increases. Third, it requires more power and higher energy costs, the higher the storage pressure is. Every 2 psi increase is an additional 1% in power consumption. In order to make sure a flow control is the right investment for you, talk with a compressed air supplier. They can assist with calculating the power costs, ROI, and help with sizing the necessary storage. Now we're going to move to strategies that involve more advanced technology and have a higher capital cost. But don't let the price tag deter you. They are well worth the investment and can truly provide lasting savings for your system. Our first example is a compressed air assessment or audit. Many air system owners don't have a clear picture of how their system operates or how much energy it consumes. Compressed air audits are a great way to baseline the system and visualize what is happening before you try to make improvements or add compressors to accommodate expansions. An audit will help you prioritize your actions as well. Knowing how much energy you use to compress air should be a primary goal. An audit will help you do this and help you identify components of that cost, such as leaks and unproductive uses. The data collected can be used to determine the optimal mix of compressed air equipment for the existing need or future expansions. An air audit from a competent compressed air professional is a first step in determining compressed air efficiency. The assessment, along with a leak detection audit and evaluation of each compressed air user, have the potential to significantly improve system performance. If you've never done a compressed air assessment, you might want to consider getting one done. This is especially true if you have had significant changes in demand, either increases or decreases, or if you are planning an expansion to your plant. A thorough assessment will provide you with extensive charts and graphs and identify areas for improvement. To maintain an optimized system, complete an audit every year. Think of it like an annual checkup. Once you get the results from your auditor, you'll want to carefully review the charts and summary. If anything isn't clear, ask questions, and ask until you are comfortable and confident with the results. You will probably need to explain them to someone else, especially if you need to justify an improvement project. Your report should include recommendations, so go through them and prioritize based on your budget and timeline. Then follow through. Adjust the timeline as you go when necessary, but commit to holding yourself accountable. Then have a follow-up audit to validate the changes are working. Our next strategy is to use master controls to monitor and control your compressed air system. Master controls take advantage of the latest technology to ensure a compressed air system is running as efficiently as possible. They continually monitor system demand and select the most efficient combination of units available to meet it. Having a master control in charge of your system can reduce maintenance costs, increase system efficiency, provide better pressure control, and minimize product waste. Some master controls have advanced capabilities, including email and text notifications, so your maintenance team is always aware of alarms, warnings, and service notifications. While master controls are more of an investment compared to other technologies we've discussed, their potential to improve system operation all but ensures a reasonable ROI. Now, I'd like to turn it over to Werner Rauer for the next part of our webinar. Werner?
Thank you, Neil, and good afternoon. I'm Werner Rauer, and today I'd like to share with you some practical tips that are useful for any compressed air system, no matter what the size of it might be. Let's begin with VFDs. Variable frequency or variable speed drive is a technology that's becoming more and more popular. And it's easy to see why. It provides excellent part load efficiency and stable system pressure. It does this by matching power to demand, so it varies the speed of the motor so it can accommodate changes in compressed air demand. Additionally, it has a minimum inrush starting current, so it has less wear and tear on the motor and drive system. VFDs can deliver significant energy savings, but please note that these savings will only happen if it is properly applied. Here are some tips for properly applying a VFD. This type of compressor is designed to handle varying demand. If the demand to meet your production needs is consistent, you won't get the energy saving benefits. I recommend you get a proper compressed air system assessment like Neil discussed earlier to understand how exactly your demand varies. Also, if you have high power costs and/or power factor penalties, then a VFD might be a good choice. This is because a VFD is more expensive than a regular fixed speed compressor, so you would need to have higher energy costs to help offset the purchase price difference and give a reasonable return of investment. VFDs have more electronics inside of them. It is not a good idea to install them outdoors where they would be exposed to rain, snow, and extreme temperatures. If you have to install your compressors outdoors, go with fixed speed compressors. Finally, if your plant has dirty power or environmental contaminants, don't go with a VFD. Dirty power is when the power quality is inconsistent or abnormal. Surges, voltage and frequency variations, and low power factor are all examples. These abnormalities can interfere with the VFD electronics and cause damage. Contaminants such as excessive dirt or powder can also do damage to the drive. Our next tip is to add pressure zones in your plant. Take a look at your processes and identify which parts need different pressure ranges. You can then section them and use different technology to supply the appropriate pressure. Blowers are great for aeration, air knives, conveying, or other processes that require lower pressures. On the other end of the spectrum, If you have a specific application requiring a higher pressure, use a booster for only that part of the process instead of the entire system. Alternately, you can use a flow controller if you have a portion of the plant that runs below regular plant pressure. For example, plant pressure is 100 pounds, but you have one or more large applications running at 60 or 80 pounds, isolate that part of the plant with a flow controller. When considering adding in different types of equipment, you'll want to do the math and consider the return of investment. If, for example, you only have a few air knives, it may not pay to install a separate blower system, but it will definitely pay to buy engineered air nozzles designed for the task rather than homemade solutions. In your calculations, be sure to consider energy and maintenance savings, capital costs for the equipment, and available floor space. Your best bet may be to work with a compressed air specialist who can run the numbers for you and develop a plan that would best fit your budget, application, and plant layout. And here's a list of common applications in a plant where you may benefit from using blowers or boosters instead of compressors. If you have any of these, take a good look and see if you might benefit from making the switch. There's potential for significant energy and maintenance cost savings. And here's one of my favorite pet peeves. More often than not, if an installation is having problems with temperature, it's because of improper ventilation. Compressors, refrigerated dryers, and heated desiccant dryers all produce heat. As you can see in the note here, compressors produce around 2,550 BTUs per hour per horsepower. This heat needs to be removed from the compressor room. Otherwise, you'll have high temperatures and reduced efficiency, temperature swings, overrunning air treatment with excess moisture, and in extreme cases, equipment shutdown. So here are some basics to look at with ventilation and also to keep in mind when you are planning your installation. Take a look here. The compressor room is located right next to the parking lot, and the car exhaust vents directly into this room. So we have got heat and fumes contaminating the compressor room. Of course, diesel truck loading docks are quite a bit more damaging. The first step with proper ventilation is to take a look at your surroundings. Check to see if you need to make any changes to protect the equipment and the compressed air supply. Remember, the air that's coming into the room is drawing into the compressor and ultimately going right into your processes. This is especially critical for breathing air applications. For proper ventilation, you need to have a dedicated inlet and exhaust pathway. The inlet should be a source of cool, ambient air, and the exhaust should pump out the hot air from the compressors and the dryers. In the first picture on the left, they have an inlet and an exhaust, which is great, but the exhaust is angled down so that hot air recirculates back to the inlet. On the right is how they redid the ducting to fix this problem. By the way, this fixed the overheating problems they were having in their compressor room and improved the overall system efficiency. Remember I said earlier the dryers generate heat? Well, when thinking about ventilation, don't forget about them. In this picture, we've got hot air from the dryers exhausting straight up to the piping, reheating the air after it's been cooled, and of course, the dryers just sitting there cooking themselves until they shut down. It is not uncommon to see condensate dripping out of the dryer enclosure when the hot, humid air hits the cold refrigerant compressor and condenses. Pressure dew point will go up and more moisture is carried over. The solution was quite simple and ingenious, using the required exhaust fan and the open grid for the one dryer shown and another at the right end of the duct, as well as cutting an opening in the back wall for cooling your inlet to these dryers. So what could you do with all this heat? Well, you can certainly recover it and use it. If you install thermostatically controlled louvers, you can duct the hot air outside in the summer month, and during the fall and winter, you can duct the heat to an adjacent room for heating. This can help keep your heating costs down and of course keeps your compressor room at the correct operating temperature and running efficiently. There are also solutions available for heating up water or both. Well, what do you think? Is preventive maintenance important? Is it worth doing? If you care about compressed air quality, uptime, and energy costs, then you need to care about preventive maintenance. It's just that simple. Lack of maintenance can lead to internal pressure drop, for example from clogged filters or drain traps, and this pressure drop can reduce your energy efficiency. The best way to put preventive maintenance first is to put together a clear plan that is customized for your plant. Here are 5 tips to consider in putting together a preventive maintenance plan. Read the service manuals for all the equipment, compressors, drains, filters, dryers, etc. If you don't have them, get them from the manufacturer. They have a wealth of information and also include recommended service intervals and what to check on the equipment. Electronic format certainly helps finding the important tasks more easily. Consider your application. The service manual will have recommendations, but you need to think about your plant. For example, if you have a high dust application, you might need to check and change the filters more often than recommended in the manuals. If you aren't sure, talk to the manufacturer. They are the experts on the equipment and can help with recommendations tailored for your application. Be careful of using aftermarket parts. I know they're cheaper, but they can cost you in the long run. Remember that your equipment was developed and tested using the manufacturer's original replacement parts, and that the service intervals are based on those original parts. The aftermarket parts may not give you the same results and can result in pressure drop and low efficiency, so buyer beware. Finally, and probably the best thing you can do, is to stop, look, and listen. What I mean is, pay attention and get to know your system when it is running at its most efficient. That way, you will be more likely to recognize when there's a problem. Finally, if you're short-staffed or in a position where you cannot commit to doing routine maintenance, then consider a service contract with a compressed air provider. Many offer annual agreements to take care of emergency and preventive maintenance. Everything is scheduled around your needs, and some even offer backup air during the repairs. On modern compressors with numerous sensors and electronic controllers, there are also possibilities for remote monitoring and servicing the unit based on real-time data or prediction rather than a fixed time schedule, also called predictive maintenance. Don't be afraid to ask for help. Between reducing unscheduled downtime and additional maintenance, you just might even save some money. So thank you very much. And now I think we have some time for questions.
All right. Thank you so much, Michael, Neil, and Werner for that great presentation. And Werner, you are correct. We are almost ready to take some questions that may have come in. Okay, now moving on to our first question. Michael, it looks like this one's for you. Should I use a refrigerated dryer or a desiccant dryer for my system?
It really depends on a combination of the requirements of the pneumatic equipment or process and the ambient conditions. The vast majority of applications will do fine with properly sized refrigerated dryers. But even in some of these cases, a desiccant dryer may be needed due to ambient conditions. For example, if the air line is exposed to temperatures below the dryer's dew point after leaving the dryer, moisture will form in the line. If the air around the pipe is below freezing, this could really be a problem. In these cases, we recommend desiccant dryers, but only for the air line that is getting exposed to the cold.
Okay, thanks, Michael, for that answer. Michael, there's another question for you. For best air quality, is it better to just go with oil-free compressors?
Not for most applications. Regardless of the compressor type, you still need to dry and filter the air. And in industrial plants, the air may contain any number of hydrocarbon mists or vapors, from cleaning solvents to cutting fluids. The oil-free compressor will ingest and pass along whatever is in the ambient air, just like a lubricated unit. Also, oil-free compressors cost a lot more, so do the parts, and labor costs are often higher on these specialized machines. Further, they are somewhat less energy efficient and they generate a lot more heat.
And thank you, Michael, for that answer. Okay, Neil, it looks like this question is for you. Does every system need 2 tanks?
It seems like a very basic question, but it's going to be a relatively long explanation. The answer is no, but yes. So again, it's a little confusing. We would prefer to have a wet tank and a dry tank in most scenarios. However, floor space is really paramount for most customers, and a lot of times there's not room for both. So you really have to take a look and see what's most important for you as a customer. Specifically, if you want a control buffer volume for a single compressor, then a storage tank on the wet side might be the place for it. If you're looking from a control volume and intermittent heavy demand events, then downstream of air treatment probably is the best case. In systems that have multiple compressors feeding the demand with a master controller, then dry tanks are really what you want to be looking at.
Thank you very much, Neil. And here's another question for you. How often should I do a system assessment?
So wow, another good question here. And I look at this as, how often do you really look at your compressed air station? Most people put the compressors in the farthest possible location, in the dustiest, dirtiest environment. But if you really want to see what's going on, you can do an onboard analysis all the time. Most master controllers that are out there now can stream data. Some compressors can actually stream data. So you can look at information on an hourly, daily, weekly, monthly basis. So take a look at what you actually have installed now and what those capabilities are. Really, a system assessment you can do yearly or every couple years. It just depends on what's going on in your station. If the demands don't change, then perhaps you don't need to look at how efficient your compressor is running. But most folks have energy savings opportunities or maybe Energy Star opportunities within their plant for efficiency. And when you have a master controller, you want to look to see if it can provide ISO 50001 type reports. Many of them do, and you can look at that on a daily, weekly, monthly basis. So, take a look at what your compressors or your compressed air system can provide to you right now. And if not, do an audit to baseline, and then take a look at what those efficiency improvements are. Because you'll find that there are going to be efficiency improvements, and then, how are you going to validate what those efficiency improvements really were? So a follow-up assessment is always a good idea, or if you opt for a master controller with the type of data analysis that I'm talking about, you can do it on board every day.
Okay, Neil, thank you for that answer. Here's another question. Should I add a flow controller or a master controller to my system?
So when you're looking at the system that you have, you really want to see whether they're compatible with a master controller. Because in the end, how the compressors operate together will make the most effect on your efficiency. If those compressors aren't going to, per se, play nice with each other via a master controller, then you want to consider a flow controller. So again, we kind of mentioned this in the training. Flow controller kind of a low-cost, low-tech idea and a decent ROI. What that's going to do is allow you to drop the pressure to the lowest possible point for the plant. When you drop the pressure, you're dropping all that artificial demand. So your leak's going to leak less, your tools are going to use less air. So it's really a big benefit. However, it doesn't do anything for your compressor. So if you do have multiple modulation compressors, they're still going to dance around and do what they were doing before. If your specific power, for example, was 25 kilowatt per 100 CFM, it's probably going to be pretty close to that even with the addition of the flow controller. Only you're reducing the demands a little bit, so that's where you're going to glean that savings. With a master controller, again, you're looking at each machine. The master controller should be adapting and deciding, hey, I need a big compressor or a small compressor for this demand. And that's where you get your efficiency gains because you're turning compressors off. There's also a question on, hey, can I use them together? This is a great question. You can, but keep in mind that the master controller alone can drop the pressure as low as possible. Again, that's where you're getting the most energy savings by reducing operating pressure. So you don't truly need a flow controller and a master controller. So keep that in mind. If you have very high intermittent demand events where you need very large volumes of air, gets back to that storage requirement that we talked about before. The bigger the storage and the higher that pressure differential in the storage, then you're going to be able to keep compressors off. So there are some cases where there's very heavy intermittent demand events that you can use both a flow controller and a master controller, but those are fairly rare.
And Neil, thanks so much for that answer. Werner, it looks like we have a few questions that came in for you. So here's your first one. How do I know if I have dirty power?
Well, that's a very good question. Typically, if you experience intermittent shutdowns or overheating of electric drive motors, that is a giveaway for dirty power. Of course, once you start troubleshooting and you notice that you have an imbalance on voltage, either between the phases or even to ground, or definitely imbalance in the amperage on the three-phase motor, that's when you know for sure that you have a problem somewhere. Another way to do it is to actually have either the power company do a power quality analysis. You can also rent some PQA meters. Some compressor manufacturers offer that service as well. And that typically then is a 1 month recording if it is something that's very intermittent, or you have a few day recording if it is something quite obvious that's just happening now. But that is typically the best way to figure out not only that you have dirty power, but also where the culprit might be, and then develop a plan on how to fix it.
Okay, Werner, thank you very much for that answer. Here's another question for you as well. How often do I need to do maintenance on my compressor?
Well, we already talked about the obvious answers, service manual, and possibly contacting a compressed air service provider or specialist. You can see this same question very often in pretty much any kind of forum online for cars, motorcycles, etc. So since every single compressed air system is unique, I would say that it is worthwhile to get the advice from a service provider or specialist to help you develop the plan, at least to start with, and then go back and consult them again when there is a major change in your system. But I would say that would be my advice for the best approach to get your maintenance schedule developed.
Okay, thanks, Werner, for that answer. Here's another question. When should I use a VFD compressor?
Well, VFDs are actually one of my favorites. However, the application of a variable frequency drive or variable speed drive compressor is not a panacea and should not be done just nilly-willy, but should be done after careful evaluation of the variance in your system demands, basically your demand profile, and of course also considering your environmental and power conditions at the plant. So again, I would highly recommend to do a system assessment and then discuss this with a compressed air system specialist.
Okay, gentlemen, and with that, we're just about out of time, so we're going to have to wrap things up. Michael, Neil, and Werner, thanks so much for sharing your expertise and spending some time with all of us today. Again, thanks for taking the time to join us for this webinar event. Take care and have yourselves a great day.